So a disjunction is logically equivalent to a conditional. So if we want to find the truth value of a conditional, we can find the truth value of the associated disjunction. But if we want to find the truth value of a conjunction, it will have the opposite truth value of its negation, which will be a disjunction, which will have an associated conditional. So if we want to find the truth value of a conjunction, we can find its truth value directly. We can find the truth value of its negation, which will be a disjunction. We can find the truth value of the conditional associated with the disjunction. This also works in reverse. A conditional can be transformed into a disjunction, which is the negation of a conjunction. If we can determine the truth value of any of these, we can find the truth value of all of them. So, suppose you want to prove if X is glurby, then X is fromulous. So we could try to prove this statement, but what else could we prove? What other statements are logically equivalent either to this statement or to the negation? We can prove the original conditional true if, well, remember, a conditional and its contrapositive have the same truth value. So we can also prove the contrapositive. If X is not fromulous, then X is not glurby. Next, remember the conditional is logically equivalent to not A or B, not the antecedent or the consequent. So let's G be X is glurby and F be X is fromulous. Our conditional is that if G, then F. This is the same as a disjunction, not G or F. And we could read not G as X is not glurby. So the disjunction is that either X is not glurby or X is fromulous, which will have the same truth value as our conditional. And so if we want to prove our conditional true, we can also prove true that X is either not glurby or X is fromulous. And remember, to prove a statement true, you can prove its negation false. So the negation of our conditional, well, that's the negation of this disjunction, and De Morgan's rules tell us that the negation of a disjunction is the conjunction of the negations. And so we have G and not F, and we can read not F as X is not fromulous, and this statement has the opposite truth value of our conditional. So if we want to prove our conditional true, we want to show that this statement is false. And so we can prove false the statement that X is glurby and not fromulous. Or consider the claim, if the determinant of a matrix is non-zero, then no eigenvalue is equal to 0. How could you prove this? Now, if you know what the determinant and eigenvalue of a matrix are, great. If not, it doesn't matter. Logic is about structure, not content. So we can read this statement as, if X is glurby, then no Y is quasit. Now, it's not absolutely necessary, but it is useful to phrase things positively. And so here we're saying the determinant is non-zero and there's no eigenvalue equal to 0. So let's avoid including negations in our statements and let S be that the determinant is 0 and Z be the statement that an eigenvalue is 0. Then our conditional, the determinant is not 0, that's negation of S, and it implies an eigenvalue is not 0, that's the negation of Z. And so we could prove true, if the determinant is not 0, then no eigenvalue is 0. Well, that's actually just the statement, but remember the contrapositive has the same truth value, and we'll form our contrapositive. And so we can also prove true, if an eigenvalue is 0, then a determinant is 0. Now remember, the conditional is equivalent to a disjunction, so our conditional becomes S or not Z. which we can read as the determinant is 0 or no eigenvalue is 0. And since that's logically equivalent, we can also prove true, the determinant is 0 or no eigenvalue is 0. Finally, we can look at the negation of the disjunction, which will be, which we can read as the determinant is not 0 and there is an eigenvalue equal to 0. Now, since this is the negation, it will have the opposite truth value of the original conditional, and that means we can also prove false, the determinant is not 0 and an eigenvalue is 0. And again, the importance here is that if we want to prove this claim, then we can prove any one of these 4 statements. We can prove any one of these 3 true, or we can prove this last one false.